All right, we're going to start with our first lesson on in Math 20-1, and our first unit's on sequences and series. And today what we'll do is figure out what they are, and we're going to start with our first type of sequence. So this little picture I have on here, you can see we have a number pattern going from 14 to 4 to -6 to -16. So we can actually see that that is a sequence, and we're going down by 10 each time. So we could actually continue this pattern. So we'd have -26, -36, and so on. And the question is saying what would be the 30th term. So we could actually list out all 30 numbers, but what we're going to see in this unit is there's some formulas and things we can use to find that out a lot quicker and easier. So we're going to start with arithmetic sequences. So this is our first topic. So Unit 1, Topic 1. All of my lessons will be numbered like that, so you can keep track of them a little bit easier. And so what we're going to do is just sort of look at what a sequence is. So you can see here we've got some license plates. So you can see the first one starts at 11, then we have a couple unknowns, and then our last one's at 35. So for it to be an arithmetic sequence, that means our numbers, the difference between them, has to be the same. So we have 11 plus something equals this plate. And then we'd have that answer plus that same thing would equal that one. That answer plus the same thing would equal 35. So we can do a little bit of trial and error. In this case, we could say 11 plus 7 is 18, plus 7 again is 25, plus 7 again would be 32. So we're not quite big enough. So let's try 8. 11 plus 8 would give us 19. 19 plus 8 is 27. 27 plus 8 is 35. So there we go. So we figured out those missing numbers, and we saw that our difference each time was 8. So guess and check isn't always going to be our best strategy. We want to have a little bit better way to solve these. So for first couple definitions, so to start with, we got an arithmetic sequence. So we're looking at a sequence of numbers, and the key thing for it to be considered that is the difference between each term has to be the same. So we're either adding or subtracting a common difference each time. So for example, here we got 4, 7, 10, 13. You can see we're adding 3 each time. So we'd say our term 1 is 4, our term 2 is 7, term 3 would be 10, and so on. And we'd say our D is 3 because we're adding 3 each time. So the first thing then you got to remember is our common difference has to be the same. So it's asking write the next two terms and then decide if it's arithmetic or not. So you can see this first one, we're going from 3 to 15, so that means we're adding 12. If we add 12 again, that doesn't give us 75. So you can see we're actually timesing, in this case, by 5. So we know that there's a pattern, and we could actually figure this out. But in this case, it's not arithmetic. It's going to be some other type of sequence. So if we go 75 times 5, we get 375, times that one by 5, we get 1875. Okay? So that one's not arithmetic. Let's try the next one. We got 2 to 3 to 5 to 8. So you can see we added 1, then we added 2, added 3. So it's following a pattern. So if we add 4, we would get 12. Add 5, we get 17. We're adding something different, so that one's not going to be arithmetic. The next one, if we add 6, you can see we get to 13. Add 6, we get 19. Add 6, we get to 25. So if we keep adding 6, we'd have 31 and then 37. So that one is. The next one you can see we got 1, minus 1, 1, minus 1, and so on. So you can see those will just alternate, so that's not. So the next one, you can see we're going down. We're going 6 minus 4 would be 2, minus 4 again would be -2. So minus 4 again would be -6 and then -10. So that one's good. We're subtracting the same number each time. And our last one, we got add 3, add 5, add 7. So we could add 9, add 11, and that one's not. So you can see we only have 2 in this whole list that are actually arithmetic because we're adding the same number or subtracting the same number each time. Okay, so we're just going to look at just those types now, and we're going to get to a formula that'll help us solve these things. So our first example here is figure out what the common difference is, and then then do the next three terms. So you can see we added 5 each time. So our D would be 5, and then our next three terms would be 17, 22, 27. This one you can see our common differences, we're subtracting 6 each time. So our next few terms would be -7, -13, and -19. Okay, another way we could write it is they could give you some information. So in this case, we know our first term is 3. Our common difference is 8, so that means we're going to be adding 8 each time. So we have 3, 11, 19, 27. And we're getting to a point now where we can actually use a formula. So this formula basically means we can find any term if we know the first term, the term whatever we're looking for, and the common difference. So you can see here's our sequence. So in this case you see our first term is -3. Our common difference is 5. We're adding 5 each time. So we can actually use our formula now to solve this. It makes it a lot easier than listing them all out. So that means our 20th term will be our first term, so -3, plus, and quite often we're going to write this a couple different ways. So we're going to write it in this case as n-1. So n is standing for our 20th term. So we're looking for the 20th one in the list. So we'd put 20 minus 1, which would be 19, and our common difference was 5. Okay, another way you'll see this formula written, and quite often we do it backwards, we write it as T1 plus D times n-1, which is the same thing. You can see we'd have -3 plus 5 times 19. And because they're multiplied, it doesn't matter what order they go in. So if we actually solve for this one, we get 92. So that means our 20th term, if we actually were to list out all 20 of these things, the 20th one would be 92. Part B now, you can see this is where the formula is going to be a little bit more handy, is to try to figure out which term is which. So we're saying what term would give us the 212 for an answer. So we could keep going and see 20 is at 92, so obviously we're going to be at like 40, 45, something like that. So what we're going to have to do is just plug it into the formula. So let's put 212 as our T of n. So think of the T of n as sort of being the last term or the one you're looking for. And that's a good way to approach that. So 212 is our last term. We know our first term is still -3. We don't know our n this time, that's what we're looking for, but we know our d is 5. So let's write it backwards. Let's put the d first, and then we have n-1. So now we can actually simplify and solve this equation. So if we FOIL that out, we get 5n minus 5. And if we simplify that, we get 212 equals 5n minus 8. If we add 8 to both sides, we get 220 equals 5n. So 220 divided by 5 is 44. Okay, so a couple more questions. So here's a different sequence. You can see we're starting at 6. So our term 1 is 6. And our common difference is 3.5. We're adding each time. So it can be decimals, doesn't matter. So first part is general term. So our general term is just using the formula and filling in as much as we can. So let's put the d in first, so it'll look like that. So our T of n then is term 1, which is 6, and our d is 3.5 times n minus 1. We can actually simplify that a little bit. We could get 6 plus 3.5n minus 3.5, and we could even simplify that a little bit more to make it 3.5n plus 2.5. So what that formula does now is it's a little bit quicker to actually solve for any term. So we can actually put T12 into this new formula. So if we just put in 12 in for our n, we will get the same thing. So 3.5 times 12 plus 2.5 gives us 44.5. So that will be our 12th term. And let's try it using the old formula just to see if we get the same answer. So our term 1 was 6, and we had 3.5, and 12 minus 1 would be 11. So 3.5 times 11 plus 6 gives us the same answer. Okay, so when they say general term, they're just looking for an equation that's a little bit simpler, and that'll get you any missing term, or we could go right from the original and you'll still get the same answer. It really makes no difference. Okay, here's a different example now. It says find two terms in a sequence that are so that we have, two terms in a sequence are 4 and 8. And it's asking what's the first term. So let's think about this. So the first one we don't know. We don't know the second one. We know the third is 4, 5, 6, 7. And we know the last one is 34. Okay? So you can see with a question like this, we run into a little bit of an issue because we don't know our first term. That's what we're looking for. We don't know our D. All we know is sort of certain numbers of terms. So a question like this, it's usually the best to sort of just work with the numbers that they give you. So if we just look at just this section of the sequence, let's for now call this term 1. And 1, 2, 3, 4, 5, so this one would be term 5. So we can actually plug this in the formula to solve for D. So let's try that. So we're going to use term 5, that'll be our last term. So we're going to use 34. Our first term is 4. This difference we don't know, but we know that there's 5 terms, so 5 minus 1 would be 4. So we get 34 equals, let's get rid of that 4 on both sides first. So we'd have 30 equals 4D, divide by 4. 30 divided by 4 is 7.5. So now let's see if that actually works. If we put 7.5 in, so 4 plus 7.5 would be 11.5, plus 7.5 again would be 19, plus 7.5 again would be 26.5, plus 7.5 again is the 34, so we got it right. So once you have that, we could use a formula again to figure out the rest, but it's probably just as fast to, let's just work backwards. So if we take our 4 and subtract 7.5, that'll give us negative 3.5. And if we subtract 7.5 again, we'll get negative 11. So in this case, negative 11 is our correct answer. Okay, so here's another one, kind of the same. So we don't know term 1, but we know that term 6 is 86. And we know that term 9, so 6, 7, 8, 9 would be 50. And we're looking for the first and the 15th. So once again, let's just look at this part only. We're going to call term 1 our 86 and term 4 our 50, just for the time being, and that's how we'll figure out what our difference is. So let's put 50 equals 86 plus D to the n minus 1, and we have 4 terms, so our n minus 1 would be 3. So if we go 50 minus 86, we bring that to the other side, that gives us negative 36 equals 3D. Divide by 3, we get negative 12. So that means we're going down by negative 12. So we could, in this case now, do like we did last time. We could work backwards to figure out term 1, or keep on going forward to get 15. But let's use the formula just to be a little bit quicker. So we know our difference is negative 12. So we're going to go back. We're going to go back to the 6 and 9 terms instead of what we changed them to. And now we're going to plug it into our formula. So let's rewrite our formula. And in this case, let's solve it for term 1. So let's use term 6 as our last term in this case. It doesn't matter which one you use, but let's pick term 6. So if term 6 is 86, term 1 is what we're looking for. Our difference is 12, negative 12. We already solved that. So if it's term 6, we'd have 6 minus 1 would be 5. So 12 times 5 is 60, so we'd have 86 equals T1 minus 60. Let's add 60 to both sides, and we get 146 for term 1. So there's our first answer. So now we can go back to the formula again, and let's actually solve it for term 15. So term 15 will be term 1, which is 146. Plus our difference, so negative 12, and n minus 1 is 15 minus 1 would be 14. So we have negative 12 times 14, which gives us 168. So that means we'd have 146 minus 168. And we get negative 22. So the formula, what's nice about it is you can basically solve for anything. Whether you're looking for a term number, a D, an N, it makes no difference. And that's all for today. That's all for this first unit.